Welcome to Maths with Bob. Today we are going to use a special formula with the fundamental theorem of calculus. Okay, so what we're going to be looking at is we're going to be looking at the integral from 2 to 6 of the square root of 2x minus 3 dx. Now the first thing we'd do is we'd actually just rewrite that in index form. So we go from 2 to 6, we write 2x minus 3 as a index a half. Hopefully everyone knows that the square root is an index a half. Then we'd actually apply this, so we'd then increase the power. You can see I've got to add 1 to the power following that little formula. Okay, so it would be equal to, let's have a quick look, 2x minus 3, to the, now 1 plus a half is 1 1/2. I'll just write that as 3 on 2. I need to now put it over this new power following the formula, that's 3 on 2. But I actually have to multiply it by the derivative of what's actually inside that bracket, which in this case is an a. Okay, so it's going to be a 2. Now, we normally add a c, but this is a definite integral, so we're now going to evaluate it between these two bounds, the 6 and the 2. So we're going to feed the function a 6 and then subtract off feed the function a 2. But we'll simplify it a little bit first. So let's actually simplify the, cancel the 2's. So it's just a 3 on the bottom. Okay, so we then have, this is equal to 2x minus 3 to the 3 on 2 all over 3. Okay, but we still need to obviously evaluate it between the 6 and the 2. Now, what do? Well, first up, we then feed the 6 into the function. Now, the 6 goes into the variable x, so we then have 2 times 6, which is 12, minus 3, which is 9, to the 3 on 2, all over 3. Now let's actually feed the function of the 2. So the 2 goes into the x, so it becomes 2 times 2, which is 4, minus 3, which is 1. 1 to the 3 on 2, and hopefully everyone knows that 1 to any power is actually just 1. So all over 3. So we end up getting, well, now, 9 to the 3 on 2. Well, that's the square root of 9 cubed, so it's 3 cubed, 27 on 3, so it's just going to be 9 minus 1/3, which is equal to 8 and 2/3. Okay, all right. So we're now going to look at substitution to try and do this. Okay, so we're going to actually do this via substitution. Okay, so here's our integral again. Now, via substitution, what we would do is we'd pick a variable. We normally let u and be equal to whatever's in the brackets, or under the square root sign in this case, 2x minus 3. Now this is a transformation, so when we do substitution we transform the integral, and we have to look at the relationship between the u and the x. So we'd have to basically differentiate this now, get du dx, differentiate u with respect to x, and that's actually, you can see here, 2. Just while we're on this, we can see we've got bounds now. These are the x bounds. So if you have a look at u equals 2x minus 3, say x was 1, then u would be 2 1s are 2, minus 3 would be negative 1. So we can see that we are going to have to adjust the bounds. Okay, but in the meantime, let's try and get an expression for dx. So what I normally do now is I multiply both sides by dx and get du is equal to 2 dx. And then hopefully we can see that in fact we want an expression for dx. So we just say, okay, therefore dx is actually a half of du. Now while we're on this, let's actually look at the bounds. Okay, so when x is equal to 6, okay, well, u would be equal to 2 times 6 minus 3, which is hopefully 9. Okay, so our x bound of 6 correlates via the transformation to a u bound of 9. Let's try a x is equal to, say, 2. Okay, u is obviously, you can see here, 2 times 2 minus 3, which is just 1. Okay, so u is just 1. So our x bound of 2 is actually now a u bound of 1 under this new transformation. Okay, so let's start applying this. We now have, well, 2x minus 3, which is u, so it becomes u to the power a half. The dx is actually a half of du, Okay, so I'm going to take the half outside, and hopefully everyone knows we can actually move constants outside the integrand or integral sign. And now this becomes du. Now the bounds are in fact, as we can see here, from instead of 2 to 6, they are going from 1 to 9. Okay, now there are a couple of things here. One of them is when I do a transformation, I need all u's in my integrand. I can't have a mixture of x's and u's. I've seen many people half do this, don't adjust the bounds, but when you do the transformation, remember, change everything to u's, or whatever the variable of substitution you chose was. Okay, so then we go, okay, well, this becomes what, a half? Now we all know that u to the half integrated is u to the 3 on 2. Now it's all over 3 on 2. Okay, or 2/3 if you like. And then we're going to integrate this between 9 and 1. Now, well, we put the, let's have a quick look. I think I would try and simplify that fraction, so I'd really rewrite that as, say, a half times 2/3, and just leave the u in here as 3 on 2 to the power 9 and 1. Okay, so then I'd say, well, you can see here that the 2's would cancel, so this would leave me 1/3 of, now put the 9 in, so it's 9 to the power of 3 on 2, which hopefully is, we can see here, 27. Okay, minus, put in 1, so that's just a 1. So we end up getting, what, 26 on 3, and if we just divide by 3, 3/8 at 24, and 2/3. So you can see here we had the same answer using that special formula as we did via the substitution. Okay, well, thank you for watching. Bye.